Hello all, and thank you for coming today. My name is Cody McCall. I am the North American Operations and Customer Success Manager for Green Valley International. And today we are going to cover topics such as LiMobile M1, which is our newest mobile system, and the compatibility and use cases with LiDAR360MLS.
LiMobile M1 Mobile Laser Scanning System. Equipped with integrated tilting 640,000 points per second, 32-channel laser, 8.9 megapixels planar camera, and 30 megapixels Ladybug 5 Plus panoramic camera. With the high-precision GNSS INS integrated navigation system, the LiMobile M1 mobile laser scanning system delivers point cloud data with a relative accuracy of less than 3 centimeters and an absolute accuracy of less than 15 centimeters. This allows rapid acquisition of three-dimensional data for roads and the surrounding environment, meeting the data collection needs for road element scenarios. The LiMobile M1 provides abundant expansion interfaces supporting optional accessories such as the Distance Measurement Indicator, DMI. It also supports a 2 terabyte hard drive, facilitating the storage and transfer of large data volumes. The newly upgraded web interface boasts a user-friendly button design for quick and easy navigation. It provides real-time visibility to collection routes, point cloud data, high-resolution imagery, and device operational status, ensuring that you are in control of the data collection process. Paired with Green Valley International's self-developed LiGeoReference data pre-processing software and LiDAR360MLS data post-processing software, it enables a one-stop data processing solution for the delivery of industry results. The LiMobile M1 mobile laser scanning system offers an all-in-one high-precision road element collection solution for road asset surveys, urban power surveys, city landscaping, smart transportation, and more. It empowers industry users to achieve efficiency innovations, bridging the gap from point cloud data to enhanced productivity.
So to introduce the system, which is called the LiMobile M1 mobile laser scanning system, this one comes equipped with the Ladybug 5 Plus. Some of the key takes from the system is that it's extremely lightweight, 12.68 kilograms. Real-time monitoring supports the display of collected data and monitor the operating status of the equipment in real time on a web interface. There's continuous operation, so hot swappability, battery design for continuous and stable power supply. And it's also a multi-industry application design. Some of the key specifications are that it has a 512 gigabyte standard SSD on board, plus a 2 terabyte hot swappable pluggable hard drive. It also allows for wireless mode and wired mode, as showed in the video. The instrument's range is out to 120 meters down to 0.5 centimeters with a range accuracy of 1 centimeter, plus or minus 1 centimeter. It does have an IP rating of 54, allows for double return up to 1.2 million points per second. And when coupled with the Ladybug Plus, you're getting a 30 megapixel, 5 megapixel times 6 cameras, CMOS, high quality at 8100 resolution. So the design is very specifically driven towards HD mapping and street mapping. In the system itself, you would receive a roof rack. You would receive the panoramic camera, so the Ladybug system, which allows for panoramic image and point cloud overlay display. LiDAR with an INS and a planar camera built in, which also allows for planar image and point cloud overlay display, and an optional DMI if needed. So just to go through our basic kind of data collection workflow, we have a base station that we would set up. It could be a third party or it could be a base from Green Valley. Set up your base station prior to the collection within your collection realm. You'll just power on the device, simple as it be, connect to the web interface via an Android device or an Apple device, any device, really a laptop. Allow device initialization, and then allow for an INS alignment, which is just pretty much setting up, allowing for a static collection to allow the device to initialize. You can start recording at that time, whether you're going to be recording panoramic or planar or both. This can be all selected within the user interface. You will continue to do your data collection as normal with the real-time visualization of the images, the point cloud, your trajectory, the equipment status, including battery and storage life. From there, you would stop the recording. You would end it with an INS alignment, same as you would in the beginning, and then you would power the device off. If collection is needed to continue on, you would just repeat the steps from the device initialization. So our data processing workflow is rather simple. You need your base station, as mentioned earlier, a Rhinex file or Navitel or a POS file. You can have a merge log file, a LiDAR data file, and a panoramic camera file. In the data processing, we have a post-process or pre-processing software called LiGeoReference, which will allow for the processing of the pose trajectory, georeferencing the point cloud, and then a colorization of the point cloud, whether that be a colorization by planar images or colorization by panoramic images. Within that software, you're able to generate a LAS file that has been corrected and cleaned, so that if you were to take it into a post-processing point cloud quality inspection and improvement software, such as LiDAR360 or LiDAR360MLS, there is no additional cleaning up that is needed. It also will go in natively to third-party softwares as well. So from the panoramic side of things, we take the panoramic image resolution in LiGeoReference and convert that to a JPEG, which in turn is used within the processing of LiGeoReference for the colorization. We have LiDAR360MLS, which also allows for colorization of point clouds as well. So you would have your profile view within LiDAR360MLS. You can do your GCP inspection within inside of LiDAR360MLS. You can do your adjustment. You can do your strip adjustment. High precision point cloud data is generated from LiDAR360MLS if there is additional needs of cleaning as well. And then from there, we have the fusion side of it, which your point cloud and your panoramic images can be used simultaneously hand in hand in order to do further analysis, feature extraction, classification, and annotation, which we will go through in this webinar. So just a couple of videos highlighting the different types of scenarios that the LiMobile handles best. So from left to right, we have the application areas that are best and most commonly used with the LiMobile. On the top left, we have road asset and survey management. This would be a total collection of the entire scene itself via vectorization, classification. In the middle, we have urban power line analysis, which is where you would be able to do power line vectorization, clearance analysis, danger points, similar to some of the other features that are in our LiDAR360 software. Road viewshed analysis allows for clearancing and making sure that vehicles can pass certain roads, go down certain streets. If trees are a potential hazard, they can be managed and monitored actively with the system and within LiDAR360MLS. On the left-hand side at the bottom, we have urban forest survey. So we have the ability to segment and individually tree ID every tree that is within the data set. This allows for easy management of urban vegetation. On the bottom middle, we have road analysis. This would allow to predictively check based on truck length, whether or not it would be capable of making a certain kind of turn, going down a specific road. There's several different features. It can generate reports related to these results. And then on the right, we have the HD mapping, as I had spoke about before, which is a total understanding of the roads, the features of the roads, the lane lines, curbs, all of that can be extracted from a collection with LiDAR360 MLS and the LiMobile M1. To highlight our software, LiDAR360 MLS, which is a point cloud feature intelligent extraction and analysis software. This software was designed and created based on our famed LiDAR360 software. Framework and all the internal is pretty much the same, but we have added additional features specifically geared towards terrestrial data, such as something collected by a fixed tripod scanner, or by the LiMobile M1, or by our LiGrip, or third party, as I will highlight now. So just a quick introduction to the software itself. We have rapid visualization and processing. We have quality inspection and accuracy improvement, including time jump errors. We have intelligent feature extraction, and we also have several different types of road analysis tools within the software itself. So we have road asset survey, as mentioned earlier, urban forest survey, road safety analysis, HD mapping, digitization of elements, individual road inspection and maintenance, along with creating digital twins and 3D real scenes. As mentioned earlier, we work with a plethora of different types of mobile mapping systems when it comes to LiDAR360 MLS. Just to mention a few: Regal system, Leica system, Trimble system. We are already compatible with those systems in order to be able to take their data and do the processing within LiDAR360 MLS. If we do not have your specific sensor, you can send us the information about your sensor, and we will be able to input it into LiDAR360 MLS for better processing of your specific data. And then on the right-hand side, we have our list of products, which from top to bottom on the left would be multiple different Regal systems that we have. Those are the M1 Pro. Those are our higher-end mobile mapping system, specifically designed for extremely accurate measurements for road condition analysis, running PCI, damage detection. That can all be done from our LiMobile M1 Pro. If you have questions about that, please do reach out to us. And then on the top right, we have the selection of backpacks throughout the years of what we've created. We had the C50, we have the DGC50, and then we had a specific unit that was a DGC50 that had a ladybug sensor on it. We continue to advance and evolve our systems based on what is best use case for the industry. So always keep an eye out that we might be coming up with something that is groundbreaking, as we did with the LiGrip system, which you can see there on the bottom right. We had the V100, the H120, and then the H300, which is a terrestrial SLAM-based system that allows for mobile kit, backpack kit, and UAV kit with the exact same unit. This unit is RTK and PPK capable, so it utilizes fusion, SLAM, and GNSS processing in order to get georeference point cloud automatically. So from top to bottom on the left, we have overlapping point cloud with panoramic images, as I had mentioned earlier. This allows you to be able to visually see what the point cloud looks like while utilizing the panoramic images instead of just a RGB colorized point cloud, which would be the representation on the left-hand side. We can overlap point cloud with the planar images in the same exact manner. That way you can see what the imagery from the camera itself that's embedded in the LiMobile looks like, or what the images from the panoramic looks like. The software can produce ortho photos and also overlapping point clouds with vectorizing, with vector editing and control of image linking between images and vectorization. So some of the key features within LiDAR360 MLS, which allows for cleaning up even third-party data, would be the LiDAR camera and bore sight calibration and accuracy assessment, also running trajectory jump errors. The software does automatically allow for 2 different types of detection when it comes to specific trajectory style jumps. As we can see on the top left, there is a clear trajectory jump. This could be caused from poor satellite coverage. This could be caused from a series of different reasons. But if you have already done your collection and say you can't go back to the city, the software does give you that second chance to clean up your data and fix your data and align it, and it will align the entire data set itself. On the right-hand side, we can see that the large-scale LiDAR point cloud registration, meaning that we have several different point clouds registering together. We're seeing them by returns, by intensity. The software can handle terabyte plus worth of data, so it is not very limited to these large data sets that are generated when it comes to mobile mapping with high-resolution RGB cameras. On the bottom right, we can see that the tools specifically geared towards the trajectory jump can be easily isolated, and we can spot those points, detect them, and extract them. So some of the key tools within our software in terms of the cloud processing tools, obviously reprojection, transformation, normalizing by ground, subsampling, removing outliers, noise filters, classification tools, vector editing, select and cutting tools, cross selection to make it very easy for viewing specific parts of your point cloud, very key focused processing sides of classification as well. Moving into the classification of the software, we have several different forms and also different algorithms related to that processing. So we have a built-in multi-scenario AI pre-training model for automatic classification of indoor and outdoor point clouds. This is a one-touch operation that allows for the end result of what you are seeing on the screen as of now. And now we also added multiple custom point cloud AI classification modes for specific industry application-based uses. And we are also adding new and more advanced ones all the time. We take input from our clients and our customers. So if there are specific industry needs that our software doesn't currently meet, please reach out to us and we will do what we can to try and complement or add that to the software. As we can see, these are just walkthroughs or fly-throughs of our data that has been processed by classification. So the specific underground parking garage classification, that is just purely designed to be a one-touch classification for underground parking garages. Very few amount of features that are within there, but it is one-touch operation. So in terms of our custom point cloud deep learning classification, you could prepare a point cloud training data specifically from a collection that you have done yourself. You can train the point cloud classification model based on your own data and your own classification methods to get your data as accurate as possible, and then utilize that data for future processing and classification methods. So you can classify point clouds using the trained model based on your efforts. And then by that, you can support multiple point cloud classification models and accuracy evaluations. There's different types. And then in terms of the actual processing, when it comes to our deep learning, we do have a weekly supervised point cloud classification mode and a unsupervised classification or supervised classification. The difference between the two is, as shown in this image, a weekly supervision only requires a 1% labeling effort of the point cloud itself in order to get high quality results of around 80+% by the 1% labeling. Or you can do a fully supervised, which is where you spend more time and it requires, I think, at least 60 to 90% of physical labeling to train the point cloud itself based on that to get those accuracies of 95 and above. But it is extremely possible for you to do so. One of the key features of MLS that really does set it apart is the concept of our automatic extraction of all types of road markings. This tool or series of tools is incredibly beneficial because it cuts what used to be hours worth of processing and post manual editing down to seconds, because we have the ability to automatically extract specific types of features. We also have the segment anything model, which allows for AI-based segmentation, both of lines, of markings, allowing for physical IDs and more information related to a specific marking other than just the vectorization result. Again, accuracies of around ±85%. Some of the road facility detection that we have with AI is based on spherical images and based on point cloud imports. So we have an image-based feature detection, whether it be signs, road signs, street signs, that can be converted with a 2D, 3D conversion. And then from there, semantic labeling and 3D vectors, which allows for signs to be automatically vectorized and then labeled based on libraries that we have available within our system. Some of the other features is the road facility detection with artificial intelligence. So this does allow for automatic road facility detection based on our AI-driven algorithms. And this can be overlaid simultaneously with the vector images on top of the panoramic images. In terms of vector mapping with multi-source data fusion, we have the quick and easy ability for 3D mapping based on point clouds. It supports over 100 vector mapping processing editing tools, supports points, lines, polygons, multi-points, and multi-polygons, multiple vector node snapping and editing modes, field calculator and sorting, multiple output formats with seamless integration with multiple different types of GIS platforms and CAD simulation platforms. We can see that vector node editing is quite easy. Line split of objects is extremely easy. Extend and trim is just a touch and pull. Symbol appearance, and then a geometric quality check is also capable of, or you are also capable of producing a geometric quality check. As mentioned earlier, you can have that overlaying panoramic images and your RGB and your point cloud on the left-hand side. From there, you can actually physically vectorize both automatic vectorization of road markings for true verification based on your RGB, which it simultaneously will produce a vectorized marking and add a layer within your RGB point cloud. So some of the other key things is the multi-source data fusion mapping. So we're getting a lot of the requests for real scenes and digital twins, automatic extraction of specific features such as windows and outlets and croppings. So these are all tools that are available within LiDAR360MLS. And as you can see, this data is collected by the LiMobile M1. So utilizing the system that we're highlighting and the MLS system, you're able to get specific types of features, including construction lines and DXF files, and get an array acquisition of your data. As you can see, the automatic extraction of the specific size windows. Within our floor plan model, it gives the ability to create 2D horizontal section mapping. It supports GIS or CAD format exports. This is being used collectively quite often with the light grip for internal mapping, but also externally it can be utilized for CAD mapping or Bentley or Trimble Business Center. So within our urban forestry survey system, it allows for fine-grained management of each tree, as mentioned earlier. So we allow for single tree segmentation and parameter extraction, including running a biomass model on it, single tree management with parameters and photos, ecological landscape thematic mapping, GVR or green viewing ratio, green volume, sky view factor, and other simulation analysis within the software itself. As we can see, we have a before and after editing. This is what highlights the amount of trees and the classification post-editing. We can see here that we had a couple trees that merged together and then we separate them, which makes it so that we have a total representation of the urban forest itself. As mentioned earlier, we have several different tools built into LiDAR360MLS that are focused towards clearance analysis, whether that be vegetation clearance analysis, specifically for overcropping, for bridge analysis, which I will go into a little bit further here. But this one is actually just highlighting that you can specifically choose your parameters when it comes to the width and the distance that you want this analysis to be based on. And then it will highlight trees that are within that area and produce a report that gives you the ability to go and manage those trees. And as we can see, we were easily able to remove them and give an effect as if these trees had been physically removed in a real world scenario. As mentioned earlier, we have different systems that provide different levels of accuracy. So our LiMobile M1 Pro is high accuracies of sub-centimeter, allowing for that type of really accurate PCI calculation, really accurate road analysis. And then in LiDAR360MLS, it gives you the ability to run those reports based on rutting, cracks, corrugation, potholes, depressions, bumps. You can choose the width and the length and the height of these features so that it is very specific to your needs and very specific to whether or not these need to be handled or taken care of sooner than later. As mentioned earlier, again, we have our bridge height limit analysis. It's an automatic calculation with a single 2-point measurement. We also provide an equal interval measurement as well, along with an analysis report that makes it very easy for client to go out, get to the location, and potentially make adjustments or make appropriate marking for visualization purposes. As mentioned earlier, we have our urban power distribution line analysis. These are automatic features that can be generated post-running classification. So we have our power lines. We know exactly where they're at based on classification and segmentation, which allows us to create height limit analysis based on road crossings or specific distribution lines or lines running through a city. We can easily detect whether or not they could be a hazard, along with also being able to detect whether the urban forestry that we are seeing is also a potential hazard, either a danger point or a potential future hazard. We can see that there's a clearance that is needed, and we can easily depict which trees are meeting that threshold or exceeding that threshold. This all is done, and a report is generated that is very easy for users to put into the field or utilize the data and put it into something like ArcGIS Explorer or Field Maps and easily get down and get to the root of the issue so that it can be solved as soon as possible. Again, as mentioned earlier, the road analysis for collision simulation. So it can input the vehicle dimensions, run a collision simulation, and create a report that is based on the results for your specific need case, which makes it very fine-tuned and extremely usable for any user who has collected data. One of the key features at the end of the day is the road section analysis, being able to truly understand what the system is seeing when it is driving, being able to utilize every bit of the point cloud, not just for classification purposes, but for the overall end result of providing an end deliverable or a resolution to an issue that cities are seeing around the world, trying to make it a much smarter, much more effective and economically friendly use case. LiDAR is definitely moving in that realm of being able to be that overall any tool use. And LiDAR360MLS is that tool that allows the LiDAR to be that any tool purpose going across multiple different industries. With road section analysis parameters, cross-section, one-way slopes, left rut depth, we have longitudinal sectional, maximum turning radius, right rut depth, max deviation, and our IRI, International Roughness Index. These are all key features that are generated from the software when collecting from either our system or a third-party system. Now I'm going to highlight some of the case studies with our LiMobile system, both in the past and the current studies that we have going on, along with current and previous customers of the system. Starting off, we have our clients, GeoPro, who is based out of Riga in Latvia. They were able to extract all of the critical infrastructure and roadway features, as I had mentioned earlier, physical classification of all the data, including buildings and trees, both high and low vegetation, complete vectorization of the tram lines, the power tram lines, the vectorization of the roads and road markings, crosswalks, streets, street signs, poles, street lights. All of these are individually extracted and given to the city as an indeliverable. This is a huge project that is going on in Riga and is actually going on worldwide at this point in time. So having a tool like LiMobile and a tool like LiDAR360MLS is one of the key features of what will set you apart from others. And having a complete digital depiction of the actual roads, again, gives an overall understanding of what a city has, including its assets, which make them much easier to manage and maintain. In Hong Kong, we worked with the Hong Kong Highways Department over a course of a couple years so far. Their whole process with LiDAR360 and LiDAR360 MLS and LiMobile system was for vegetation clearance analysis on urban metropolitan roads and highways, as highlighted earlier. Decision makers about the areas in which vegetation along roads is blocking line of sight of drivers and oversized vehicle transportation. As we know that as we order more things and as we get more vehicles in and out of cities, we have more and more trucks that are coming into cities. So we need to easily manage and make sure that no accidents occur. Any type of bottlenecks can cause major issues in downtown regions, specifically in very tight-knit downtown regions. So the goal there is to provide a safer environment for all drivers and also all pedestrians. This specific project is an ongoing 5-year project and is continuing on at this point in time. Another case study that we have was at the Sydney Airport Gateway project. This was in 2022. The construction began in early 2021 of a new terminal at Sydney Airport. Our systems were utilized with our partners there in order to run data collected along the Gateway project site so that they can run active management of volumes of stockpiles and track construction progress in a real time. We do have several different types of volume analysis, change detection analysis, deviation analysis, and also real-time construction reporting. All of this is some of those key features that really do make LiDAR360 MLS stand out, and then coupled with LiMobile M1, you get a total overall encompassing result from your system. And then in a collectiveness, it's just easy and evaluate and compare the use of materials with the actual progress. So there is a huge push to know exactly what's happening in real time so that the least amount of money is wasted and the least amount of time is also lost so that projects can maintain their specific set deadlines from the get-go. One of our clients, DPROM, based in Thailand, they did a specific series of scans within Bangkok using MLS and the LiMobile. Their key goal was for road asset surveying and urban power distribution line analysis, similar to what we had shown earlier, making sure that trucks can move through these cities, that some of these areas were originally very small and not very heavily trafficked by transportation means. In regards to commercial trucks and large shipping containers. So trying to make sure that these trucks can go through the city of Bangkok, which can be extremely busy without any holdups or any types of backlogs and backups. So another project that DPROM did was actually at the Nanakan Airport. It was a runway expansion. The system was used to obtain point cloud data that met the requirements of high-level accuracy. This way, they were able to go out and actually extend the runway itself. Utilizing the system, they were able to get those results, run the reports that were needed, provide that sub-centimeter or centimeter accuracies That way that the system and the clients could trust what they were doing and get out and do the expansion of the airport, which has been completed or is in the process of being completed. Another one of them is just the overall aspects of road asset surveys. This comes across the board. So 23 different ground symbol feature templates in 3 categories, including all types of road markings. If there's road markings that we don't actually currently have within our system, please let us know and we will add them. Some of the additional features is, again, the automatic extraction of road markings with an accuracy of 80% or more, depending on the type of feature, the marking, the scan itself. Also semi-automatic extraction of road facilities, such as certain types of power lines and certain types of poles. There is automated road facility extraction. There's also templates that you can create your own template based on physical data that is within the point cloud, and then utilize that to try to do further processing on other known markings within the same point cloud. And then again, multi-source data fusion mapping. This one is a highlight of an urban forest survey. So this was a massive data set. It was, I think, over 409 gigabytes. We did individual tree segmentation of the entirety, gave biomass of the entirety. There was also backpack data within there, but again, poles, fences, power lines, static individuals, both people and cars, dynamic individuals and people and cars, individual object segmentation, as mentioned, so with the trees and the poles and the fence, and then overall parameter extractions, such as the semantic classification, and again, getting a total encompassing picture of a city, so that when a city management system needs to go out and do something or make changes or facilitate their assets, the system itself is designed to make it as easy and as user-friendly as possible in order for clients to get the job done as soon as possible with as little wasted effort and also as little wasted time. Wasted funding. Our last project case study was done in New Zealand by our partner Geospace, where they conducted a series of MLS scans on the Auckland's North Shore. Similar to that of our Thai partner, they were doing urban analysis and urban power distribution line analysis. As you can see, what is being highlighted here is automatic feature extraction, deep learning classification, vectorization, along with RGB colorization, giving you, as mentioned, a total 3-dimensional depiction of what the scenario is. So it's a one-time scan operation that can be used 10 times over, instead of having to go out over and over and over and get the same data again and again. You have that data already stored, already set up. And as you can see, the amount of data that is possible to be able to be processed in the software is exponential, and it's growing continuously with our growing limitations of the software and or non-limitations. And again, if there's features or signs or specific types of designs within your specific need or your specific client's need, then please let us know. We will do exactly what we can to try to make sure that that is possible within our software, within our system. Collectively, the LiMobile is a very affordable survey grade accuracy design that is very user friendly. It really does not take someone who has a PhD in order to operate it. So if you have several people with several different vehicles, you can trust that the operation itself is easy enough that once it's learned, it is very much so. You're literally just driving the vehicle. Processing wise, LiDAR360MLS has so many features and tools and abilities that I only covered maybe 1% of what is capable within the software. We will continue to do more and more webinars, more and more both in-person demos and workshops that we'll be hosting at our office in Berkeley, as well as around the world with our partners. Any interest or any questions, please reach out to any of the partners that I mentioned if they're close to you locally. If you have interest of working with us directly, please reach out to us via multiple different methods. We have our info@Green Valley INTL email. Our website is greenvalleyintl.com. And then we also have a around 100 plus videos that have been uploaded to YouTube, which specifically go over individual tools within LiDAR360 MLS and also within LiDAR360, depending on what your use case and use needs are. And again, if we don't meet those needs or requirements, please let us know, and we will do absolutely everything in our power to add or be able to at least accommodate to an extent of whatever that need may be. We are constantly changing and evolving and making our systems better and more suited and more user-friendly. We do believe in a much better and a much more environmentally effective future. We do believe in the concept of potential smart cities, and we do also believe that our systems have the ability to produce what is needed in order to get those types of jobs done. So this webinar is pretty much one of the first of many that we'll be highlighting specifically tools within LiDAR360 MLS and a compilation with our systems, but also third-party systems as well. So just know that LiDAR360 MLS is not only used for our systems, it is a open system that will allow you to utilize your own data that you currently have. But there is also the side that you can move over to the M1 at a much more effective and cost-effective method and get the results that you've seen from this webinar. So if there is any questions or any concerns or requests, feel free to reach out to us. And we would love to also highlight any project case studies that any individual may have with our system, such as the next one, which is one of our close contacts from Canada. He's a professor in Canada, and his name's Ted. He was able to take data collected from a third-party system and run it through LiDAR360 MLS and truly highlight the side of what used to be ours with Python and coding is now truly just a one-touch effort, getting results right away, knowing what you have, and being able to maintain those and manage those in an extremely effective way. This video that we're seeing here was done with the GeoSun LiDAR sensor. But again, our system, their system, LiDAR360 MLS is not shy. It is willing to work, and we would be willing to work with other systems. We just need information about them so that we can add them in. The AI side of Green Valley is moving in a direction that is extremely fast and progressive in the world of AI. So I would definitely stay in tuned for ever-evolving changes and recent updates coming within the next 6 months. We will continue to strive to be a company that provides a turnkey solution for all of our clients, whether you're a dealer or an end client. We want to make sure that users are as well versed and knowledgeable about the cases and use cases and also abilities of our software. So please feel free to reach out to us at any time. You can reach out to me directly or anyone from my team. The last one that's highlighting is just the overall encompassing side of a high definition map production. As we know, most self-driving vehicles, one of the key features that they utilize is results from a high definition map. This allows them to understand lane lines, maintain lane lines, typically maintain speed limits, hit stops, understand the road itself. LiDAR360 MLS and the LiMobile M1 is a tool that is extremely, again, cost-effective to give you this result that would allow for your own style of pre-training for ADAS or utilizing the system in your own methods as vision or getting the results that you need that can be sent as in deliverables to each customer independently or as a group. So that everyone can understand that when you put the efforts in and when you utilize our turnkey solution systems, you're going to get a result that is worthy of time and worthy of effort. This case is the garage map. So in this specific use case, we utilized the M1. We were able to go through a garage similar to what I showed earlier with the classification, do the vectorization of the entirety of the garage, including the road markings. So that way this can easily be put into something like Revit and utilized for real world use cases, along with the accuracies, knowing what we see, which used to be hours of efforts of manually vectorization, where we have cut that down to mere minutes, which again impacts overall quality and efforts, and also budgets and meeting deadlines in an effective and prosperous manner. And that is the end of the webinar. So I wanted to, again, thank everyone for attending, both here live and all viewers who will watch post. Please feel free to reach out to us. Again, my name is Cody McCall. I'm North American Operations and Customer Success Manager for Green Valley. My email is codymccall@greenvalleyintl. Please send us a message in the registration link. You should be able to also reach out to any one of our staff members that are in your local area, and we'll do what we can to work with you as effective and efficiently as possible. And I will open the chats to see if we have any questions. Please feel free. Yes, I have a couple people here. So it doesn't look like we have too many direct questions right away, but I will cover something with the LiMobile M1. The roof rack system is a fixed distance for the roof, for an actual roof rack. So typically what is best suggested is a vehicle that has side rails and then a purchase of like a Thule cross rail system. The Aero style roof rack system is most suitable for the roof rack because of the gap that is associated with it, but it would work with almost all regular brand roof rack systems, including some vehicles that have their built-in roof rack systems. The system is capable of working with those. Does come with cases, individual cases for each part of the system. There's a case for the LiMobile sensor itself. There's an individual case for the Ladybug system. There's a case for the roof rack, and there's a case for the battery and the accessories. The device does come with 5 batteries. It does come with everything that's needed in order to be able to operate and function right out of the box. Connection via laptop is one of the key methods that I utilize to view the real time while driving. It's very effective. It does utilize Bing online maps for real-time display of trajectories. And again, there's just several features within the software and the system itself that make the compatibilities between the two extremely effective and user-friendly. And as of right now, it can be accessed again by any web browser at this point in time. So it's very easy to utilize. Can switch between single and double return, can switch between the frame rates as of right now, 1 to 5 second frame rates for the Ladybug. Again, you can turn on and off the panoramic camera prior to collection if you only want to collect with the planner camera, or if you only want to collect with the Ladybug camera. This can all be done within the user interface, including, as mentioned, the power life, and also the storage life or the storage capabilities is visible within the user interface. And then within LiDAR360MLS, you have additional features of cleaning up data if needed. And as mentioned, one of the key features is our newest tool for the trajectory jump repair. The automatic detection of trajectory errors and issues is a very strong and key tool that we utilize in order to do those repairs as effective and efficient as possible. Okay, and I see that if we don't have any more questions, I will go ahead and end this webinar. And again, I wanted to thank everybody for being here. If anybody has any further questions that arise later, please let us know. And yes, thank you again for being the best part of Green Valley International and helping us map the world in 3D.